Okay, so welcome back everyone. For today's part 2 out of 2 series for vector combination problems, or just a singular vector combination problem in this case. Today's video is going to be focused on not another vector combination problem, but alternatively, I would like to give you, a visual representation or intuition behind why behind the combination of vectors to get to receive another vector c in this case. So I have given you the values of these column vectors here already. They're the same exact theoretically, or hopefully they are. Yep, they're the same exact values, and today I'm just going to show you visual representation again, a proof sort of about why this works. So let's just get started by actually plotting these vectors, their magnitudes. So let's first plot A. So this is equal to x, this is equal to y. So 4 in this direction and -2 in this direction. So it looks, I wrote these a little off with everything else, so I'm just gonna do something like that maybe. Okay. So 4 in this direction, just like that. That can be vector, that is vector A, right? And we can draw a line like so. Right? Now let's draw vector B, so that's -1 here. Okay, no, this one doesn't really matter. And then up 5. 1, 2, 3, 4, 5. So it's something like this, vector. That was a bad line. Well, vector B. Vector B, okay. And how about vector C? Well, let me shine some more light in this direction. Well, vector C would be located here. X1 when x is equal to 1, y is equal to 13, so all the way up here. I'm not going to bother drawing a line over, or maybe I could. I will. Why not? That was actually quite a nice line. Okay, and this is vector C. Okay. Let me just make sure this is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yep, 13. Okay, so now what we saw in this problem here was that it took one of these matrices or vectors plus 3 of these vectors here, and that became equivalent to this vector here, or vector C. And we can visualize the same thing here by starting from A, which is the one vector, right? And then placing B here, and essentially transforming B here on this side here, and adding B 3 times, right? That's equivalent to multiplying by 3, and adding it to vector A. And theoretically, after that process, it won't be perfect since I graphed this. My handwriting is set back, and it won't be as nice of a graph as it would be if it was computer generated. But besides that, what would happen is we should get to vector C, right? Because that was our result. So let's graph B starting from A all the way up to here 3 times. So theoretically, it should only take us 3 vector B's. So let's write it out. So it goes 1 to the side and 5 up. 1, 2, 3, 4, 5. So it takes 1, 2, 3, 4, 5. So it goes to 3. It goes out 1. So transforming it over here. So let's just classify this as B1. Okay, let's go again. So 1 to the side, 1 to the side, and 5 up, so should go to 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8, right? 1 up, so something like that. And final, as you can see, we're getting very close, right? Obviously, it's not perfect since all of these will be different sizes. Anyway, one more to the side, right? One more to the side, and 5 up. So that's 1, 2, 3, 4, 5. Sorry. Is this 5 up? 1, 1, 1. Is it 1, 2, 3, 4, 5? Oh, this should go up one more, right? Because this is starting here, this is 5, and then this is 1, 2, 3, 4, 5. Yeah, it should go up to here, sorry. So, looking awfully close, right? And then finally, we go up 1, 2, 3, 4, 5. And we go to the side 1. And what do you know? We've reached vector z, as you can see. So this was b2, vector b2. And this was, sorry, that doesn't look like a 2, does it? Vector b2, and this was vector b3. So it took us 3 b's to essentially get up to vector c. And that was essentially that can be described as analogous to multiplying, and it not even analogous, it's actually computationally equivalent to adding one of these matrices and adding 3 of these matrices, and that's equivalent to this matrix here, or C. So this was, wow, a rather short video, so thank you everyone for watching. Hope you enjoyed, and have a nice day. Bye-bye, everyone.